Dear student, today we are going to complete the other forms of energy. At the end, you will know what is meant by potential energy, types of potential energy, calculating of gravitational potential energy, and conservation law of energy. The second form of energy is potential energy. Potential energy is stored inside the object. It resulted due to a change in position of object or change in shape of object or maybe change in the state of object. Potential, this word means that energy has the ability to do something useful but later on, not in same time. Types of potential energy. Potential energy resulted due to a change in position of the object, change in its shape, or change in its state. So potential energy divided into many types depending on the way at which energy is stored inside the object. First form of potential energy is gravitational potential energy. This type of potential energy resulted when the position of object change. When we change the height of object from the ground, it means that this object stored potential energy in the form of gravitational potential energy. Second type of potential energy called elastic potential energy. This form of potential energy resulted due to a change in the shape of object. Same in spring. When we compress a spring or stretch a spring, it means that the shape of a spring will change. This means the spring stored inside it elastic potential energy. Third form or third type of potential energy called chemical potential energy. This type resulted when a fuel burns. The energy is released by chemical reaction. This form called chemical potential energy. Fourth type of potential energy called electrical potential energy. Electrical potential energy, as we know in electrical circuits, the current is a flow of a tiny of charged particles called electrons. Electrons can transfer energy from a battery to a light bulb, so it's called electrical potential energy. Last form or last type of potential energy is called nuclear potential energy. As we know that atom has a nucleus at its center, atoms made up of tiny particles which held together by strong forces. In some atoms, the particles become rearranged or the nucleus splits and energy is released. The energy released in this case called nuclear potential energy. So we have 5 types of potential energy depend on the way at which the energy is stored inside the object. Gravitational potential energy is defined as the energy that's stored inside the object due to a change in its position from the ground. So this type resulted from a change in position. As we see in this figure, the blue pole has potential energy because of the Earth's gravitational pull or its position above the ground. But when this pole is fall down, it means that its potential energy will decrease till this pole reach to the ground. It means the potential energy equals 0 because there is no height from the ground or there is no pull or gravitational pull from the earth. So gravitational potential energy depends on the height from the ground and it is stored inside the object due to change in its position. Calculating of gravitational potential energy. Gravitational potential energy take the symbol of PEG. Letter P refer to potential, E refer to energy, G refer to gravitational. So PEG mean gravitational potential energy. Gravitational potential energy can be calculated by using this formula, which is mass times the gravitational field strength times height. So PEG equal m times g times h. We know before g refers to gravitational field strength or acceleration of free falling, which is constant value equal 10 Newton per kilogram or 10 meter per second square. Sometimes we can use 9.81 instead of 10. So the formula that can be used to calculate gravitational potential energy is mgh. Gravitational potential energy, also scalar quantity, has only magnitude and its unit is joules. Same kinetic energy, so any form of energy measured in joules and is a scalar quantity. Factors affecting gravitational potential energy. From the last formula we know that gravitational potential energy can be calculated by using mass times the gravitational field strength times height. It means that first factor is mass or object's mass. Gravitational potential energy is directly proportional to mass of object. It means when mass increase, gravitational potential energy also increase, or when mass decrease, gravitational potential energy also decrease. The more mass an object has, the more potential energy it has. Second factor is height over the ground. Gravitational potential energy is directly proportional to the height. When the object found at maximum height, it means maximum potential energy, but when the object at the ground, it means gravitational potential energy equal 0. As height increase, gravitational potential energy also increase. So the higher an object, the more gravitational potential energy. Now we are going to solve some questions related to this part. First question: if I want to drop an apple from the top of one of these three things, where will be the most potential energy? We have building, chair and crane. Which one has most potential energy? We know before that potential energy or gravitational potential energy of an object depend on its height or its position from the ground. Which one has higher height? Yes, the answer is picture A, because the higher the object, the more potential energy. Second question: what is the potential energy of a 0.3 kilogram ball lifted to a height of 5 meters above the ground? In this case, we want to calculate the value of gravitational potential energy, so we'll use the formula m times g times h. M, the mass of the ball, which equals 0.3, times g, which is constant, equal 10, times height, which equal 5. So gravitational potential energy in this case equal 15 joules. Energy transformation. Energy cannot be lost or cannot destroyed. This is called conservation law of energy. As we see in this figure, this person starts motion from the ground with maximum kinetic energy. When this person goes up, the kinetic energy transferred to potential energy. So kinetic energy on the top equals 0, but this person has highest potential energy. When this person moves down again, the potential energy transferred also to kinetic energy. So energy can be transferred from one form to another form. Energy cannot be made or destroyed, but it can change from one form to another form. This is called conservation law of energy. Also, energy may be lost in the form of thermal energy, but in the presence of air resistance or in the presence of friction force. So energy cannot be made or destroyed, but it changes from one form to another form. From this figure we can conclude that at the bottom this person possesses only kinetic energy. because there is no height above the ground, potential energy equals 0. So at the bottom, kinetic energy maximum and potential energy equals 0. But as the person goes up, the potential energy increase and kinetic energy decrease. So at the top, potential energy will be maximum value, but kinetic energy will equal 0. And between top and bottom, the person have potential energy and kinetic energy, because the person move with speed and there is a height above the ground. So between top and bottom we have two types of energy, which are potential energy and kinetic energy. Ke at the top equal Pe at the bottom equal addition of potential energy and kinetic energy in between. It means when kinetic energy in the bottom equal 100, potential energy at the top also will equal 100. The summation of potential energy and the kinetic energy in between top and bottom also will equal 100. It means that energy is conserved. Energy cannot be lost or destroyed. Now we are going to solve these questions that are related to conservation law of energy. A car travels along a frictionless roller coaster track. At point A, the cart is at 10 meters above the ground and traveling at 2 meters per second speed. What is the velocity at point B when the cart reaches the ground? We have this track. This track is frictionless. It means that no energy will lost. We want to calculate the velocity at point B. The cart started with a velocity of 2 meters per second and its initial height 10 meters. We need to calculate the velocity at point B. We know before that energy is conserved. It means that energy at point A equal energy at point B. So what are the types of energy at point A? At point A, this cart has two types of energy: potential energy due to the height and the kinetic energy due to its speed. So at point A we have kinetic energy and potential energy. At point B we have only kinetic energy because the car reaches to the ground. There is no height, so no gravitational potential energy. So at point A the cart has gravitational potential energy and the kinetic energy equal the energy at point B, which is kinetic energy. So mgh plus half mv square at point A equal half v square at point B. He didn't give us the mass, but mass can be cancelled because it found on all parts of the formula. So substitute g equal 10 times height equal 10 plus half times 2 square, which is the speed at point T, equal half times speed at point B, speed square at point B. So 10 times 10 equal 100 plus 0.5 times 2 square equal 2, equal 0.5 times v square. So v square equal 102 divided by 0.5. So v square equal 204. By taking the square root, so v equal 14.2 meter per second. This is the end of our lesson. Thank you my student, but try to solve the homework that uploaded on Moodle.